Okay, so I'll start by showing a small video of this robot on a moving grid. So basically, what we're going to solve today is a robot on an infinite moving grid. I just want you to remember what you're seeing on the video. Yeah, so I'm going to show you something else as well. So basically, you're able to see the grid I'm seeing.
Yep.
Are you guys able to see the grid I'm showing here?
Yep.
Yeah. Okay. Right. So the problem statement is like this, right? You have a robot simulator. A robot factory test facility needs a program to verify robot movements. You have an infinite grid. The robot can face north. Sorry. The robot can face north, it can face south, it can face east, or it can face west, and it can move any either towards the north, south, or east or west. And you could place the robot in any one of the coordinates. This is 1 1. This is 1 1. This is 1 2. Any of the coordinates, and you can give some instructions which can be RAALAL, means turn right, means the robot will start, if it's facing north, it will start facing east, and then turn left. Advance means it will move one, sorry, it will move in this direction. And turn left means it will turn and face this direction, and then advance means it will go in this direction. And at the end of it, what we are basically testing is what is the final position of the robot. For example, a command like RAALAL means, let's say you start from 1 1, let's say you start from 3 8, 3 8 3 and 8, sorry, 3 and 8. Okay, it goes out of it. But after all these instructions, what is the final coordinate of the robot? That is what we are measuring. Okay, so let me get straight to the tests. The tests, you can think that I'll try to group the tests. Simulator test. You're basically testing the robot bearing, saying that it can either face east, west, north, or south, and you basically issuing a command orient to either face the facing the robot in either of these directions. And when you call bearing, it is going to return each of these directions. And you should raise an argument error if the direction you're passing is not one of these four, and you're then testing it turning right, turning left, and turning left, right? So let me just show you how this would work in the code. Yeah, so I've just created a variable bearing, and and this function would solve most of the some of these two tests, this function. And turn right and turn left would solve these tests: turn right from north, right from east, right from south, and right, all of these 8 tests. So what I've done is I have created an array of directions: north, east, south, west, and these are in clockwise manner, right? If the robot turns right when it is in north, it will get to east, and if it turns right again, it will get to south, and if it turns right again, it will get to west. So the way I'm solving it is I'm going to get the current direction index of what is the direction of what is the index of the direction in this array, and incrementing it by 1 if it is if you have to turn right, and decrement it by 1 if you have to turn left. So either going from north to west or west to north. Because I've already ordered this in a clockwise direction, this one expression is going to help me solve a bunch of these things. Okay, so the next thing is the next thing that is testing the robot coordinates. Robot at, you can place the robot at any of the coordinates. It should return those coordinates. So this is how this function would solve that, make that test green. Then these other robot coordinates, the same function would make this as well green. Then you have test advance when facing north. You're basically moving ahead. When you're facing north, you're basically coding for an advance. So basically this function is when you're facing north, you're incrementing y by 1. If you're facing south, you're decrementing y by 1. If you're facing east, you're incrementing x by 1. If you're facing west, you're decrementing 1 by 1, x by 1. So that basically makes these tests green. Okay, then you have the simulator, right? You need your test instruction for turning. So basically you need some instructions instructions. So basically you're testing for L, R, A. There are 3 instructions: turn the left, turn right, and advance. So I'm just like parsing the instructions, splitting the string and splitting it into characters. And if it is L, I'm returning the function turn left. Turn left is the function in robot, and turn right is also again another function in this class, and advance is another function in that class. And what happens is that for a command like RAAL, it will give me a set of instructions which is turn right, advance, and then turn left. So the final thing is testing passing these instructions to the robot object here. So you're going to place okay, then you need to have another place method. The place method just calls the at method. It uses the coordinates and the direction, and places the robot in a particular grid and the orientation. And then you're going to evaluate a set of instructions and pass those instructions to the robot. So you give a string, and this function will give a list of instructions, and that is going to get passed on to the robot, right? You call the instructions method here, and for each of the commands you send that command to the robot, and that's how you basically solve all of it. So let me run. Oh yeah, so we have all the tests passing. Yeah, let me show it again here. Oh, wait. Okay, just give me a minute. Okay, so all the tests are passing. So that's it. Any questions?
Cool. Thanks, Hemanth. That was great. It looked kind of fun as well. So that's really cool. Does anyone have any questions?
Yeah, did you wire it up to an actual bot, or did you use it just in software, like is it a simulator? Is it a simulated robot, or did you actually have a little motor or something?
So this is just Exercism. There are a bunch of tests, and we just write code to make the test pass.
And once
So
it passed the software, then you would load it into the bot later, would you? Like the little device. How would you test it on the little robot? You give it
But
to
this-
someone
this-
else that run it in his machine, is it?
this wouldn't work on a a real robot or anything
Okay,
like that.
fair enough.
Yeah, it's just a Dwight. It's just a simulation
It's a
because
simulation.
Okay.
yeah, we
understand.
each month we do we set an exercise for someone to try and solve, and so the idea is you get given the problem and a bunch of tests to pass, and you have to write the code that will make the tests go from red to green, and that was what Hemanth was doing.
Is that what you call exercism? Is it that test? Is it? Or that
Well, no,
exercise?
it's Exercism is the website that hosts the set of problems that we sort of
okay.
choose from.
Okay.
I'll introduce those in a second, actually.
Good idea.
yeah.
I didn't know that.
No, that's okay. No, I'm happy to. All right. If no one has any questions, we'll move on. Thank you again, Hemanth.